So what's new about this question is now it's tangent with a subtraction on the inside there. Okay. If I were to subtract those, it would probably be an angle that's not really nice to work with. So it's actually nice that it's left as 4 pi over 3 and pi over 4. So I'm going to come up here to my identities. These were the first four we dealt with. And now we have these new tangent ones. Okay. Again, tangent is being subtracted. So I'm going to screenshot that and bring it down a little bit lower for us. Okay. Now, when I always talk about the skeleton step, I highly recommend using it in this question because there's so much happening there. So 4 pi over 3, that is in the A spot, and pi over 4 is in the B spot. So again, I'm going to trust that skeleton step, that it's worth my time to write it down. So I'm going to leave it as tangent minus tangent all over 1 plus tangent times tangent. So again, I'm not going to fill any of that in right now because I want us to see where different things are coming from. I'm also going to change this color to another one. Okay, so we've got 4 pi over 3, and that's going to go wherever I see my alpha. So 4 pi over 3 right there. And then it also goes in the denominator, 4 pi over 3. And then pi over 3 is going to go everywhere I see beta. So pi over 3 and pi over 3. Now, to actually evaluate those, you need those two triangle situations, which if you remember, pi over 4 is 45 degrees. So that puts you in the first quadrant with a radical 2, and 2. And 4 pi over 3 is pi over 3 past 180. So pi over 3, that would be 60 degrees, giving you radical 3, 1, and 2 for that triangle. All right, so the tangent of 4 pi over 3, that gives me radical 3 over 1. And the tangent of pi over 3 gives me radical 2 over 2, which that is just going to be 1. Remember, everywhere where you see a sine, cosine, or tangent should get replaced with some fraction. So the tangent 4 pi over 3, I'm going to keep that in green. So that's going to be radical 3 over 1, or just radical 3. Big old minus. And then the tangent of pi over 4, which I wrote as pi over 3. I need to fix that. Sorry about that. Our answer still works, but the tangent of pi over 4 is 1. Again, that's radical 2 over 2. And then we've got our blue 1 out there from the identity. So we got 1 plus, and then the radical 3, and then the pi over 4 is just times 1. Now, on a normal situation, that would be nice to just leave it like that, giving us a final answer of radical 3 minus 1 over 1 plus radical 3. However, my math lab will probably yell at you and want you to rationalize that to the best of your ability. So remember, we have to get those radicals out of the bottom. So again, if you can get to here, that's really all I need you to do by the end of the day. But to actually plug that into a MyMathLab, you would have to rationalize. And that's where you're going to have to multiply by the conjugate. So I'm going to copy that and multiply by that conjugate, which would be 1 minus square root 3 over 1 minus square root 3. Again, try not to get too stressed about the rationalizing because that's just for another day here. Now, you're going to have to FOIL the top and FOIL the bottom. So when you FOIL that top, you've got radical 3. Outside would be negative 3 because of radical 3 times radical 3 is just a 3. Inside is minus 1. And last is a positive square root 3. When you FOIL the bottom, you've got 1. Outside is negative radical 3. Inside is positive radical 3. So that becomes 0. And then minus radical 3, which is just 3. Giving you a final answer of, on top, you should have 2 square root 3, because you have 2 radical 3's minus 4, all divided by negative 2. And this is kind of lame, but you can actually go a step farther and pull out a 2 from the top. And you can cancel out those 2's, and you're left with square root 3 minus 2, all over -1. And if you want to go even farther, you can make that negative radical 3 plus 2 as a final answer. Thanks for sticking around for the whole thing. It's kind of tough.